There's this perception that drone delivery is 10 to 15 years away because the technology is not there, the regulations are not there, the procedures not there, et cetera. But I think what we demonstrated in Lawrenceville is there are absolutely things that can be done today, and we can do things at scale today that may not have been possible even 6-8 months ago.
You're listening to the Drone Raido Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Raido Show podcast, episode 273. Is it possible to deliver packages with drones under current Part 107 rules? Today's two guests say they already have. Both are from DroneUp, a drone services company that provides end-to-end aerial data solutions by matching an organization's data collection and delivery needs with the right hardware, software, training, pilots, and program integration requirements. Brendan Stewart is the training director responsible for training and program development for enterprise and public safety clients. Joe Fuller is CIO and designs aerial data capture and processing for clients to ensure a return on investment in their drone projects. In early April of this year, the duo led a series of tests to demonstrate package deliveries by drones under Part 107 regulations. Over the span of 4 days, the exercises focused on delivery to residential and commercial areas with the aim of identifying best practices for safe operations. In this edition of the Drone Raido Show, Brendan and Joe talk about DroneUp, the last mile drone delivery challenge, and the lessons learned from the demonstration project. But before we hear from Brendan and Joe, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to DroneRaidoShow.com/donate. Now let's learn about the last mile drone delivery challenge with Brendan Stewart and Joe Fuller of DroneUp. Let's pick up the interview where I asked Joe and Brendan to introduce themselves.
I'm Joe Fuller. I'm the CIO of DroneUp. In my role as CIO, which is Chief Information Officer, I look at how does that information help the end user customer? What's the deliverable from an aerial capture that is going to provide a customer a return on investment through that information that we've captured? So I look at what information are we going to capture it, how are we going to capture it, how are we going to process it, and what's the deliverable back to the customer that provides them an ROI. I head up our engineering and R&D group.
And Brendan, tell us about yourself.
I'm the training director here at DroneUp. So my area of responsibility are the people, the process, and also the compliance to get done the jobs that DroneUp needs to do to service our customers and our community at large. So I'm responsible for developing the standard operating procedures through which we do some of these more complicated operations like delivery operations. I manage a lot of the compliance processes for doing the waivers that DroneUp holds for night operations and shortly for overflight of people. I'm responsible for doing a lot of the training. So when our pilots come into a brand new use case, a lot of the pilots that we have in the network have not done delivery before because delivery is pretty novel to the industry. I developed the training infrastructure around that to ensure that DroneUp's clients, wherever they may be, in the United States and in the world, receive the same high quality services regardless.
Tell us about the company. What does DroneUp do?
DroneUp is a drone services company that operates across the United States. We have an app in the pockets of 10,000 Part 107 certified independent contractor members of DroneUp. And what we do is we define missions for a particular job that needs to be done for a client. And then we advertise the details of that job across our network. And then we vet the pilots that respond. We've already vetted those pilots in terms of their 107 certificate and other certificates and other experience they have. And then we assign the mission to a particular pilot, share the details, lead the pilot, direct the pilot of what to capture and how, and then qualify the results, the data that comes back, quality assurance, and then process it and deliver it to the end user customer. So we're a drone services provider, primarily in the United States. We have members, I think in the latest count, 56 other countries, but we focus our operations primarily in the United States.
DroneUp is not the only drone services network, but in recent years, the company has emerged as one of the leaders. Why do you suppose that's happened?
There are a couple things. One is we're not afraid to do the complex projects. We've had customers approach us with challenging applications, and we'll figure out what it is. Some of our colleagues in the industry, rightfully so, are trying to find an economic model that works, and so they want to keep their mission simple and repeatable, and which we also want to do that. But we are willing to take on the more complex, novel missions that require some thinking that hasn't been done before, or laying down ground control points, which end up being complicated and expensive to get, centimeter level accuracy, that kind of thing. So that's one reason. Another reason is the executive team that came together to found DroneUp. We're actually all business folks that became drone enthusiasts rather than drone folks who tried to find a business model that would sustain our desire to work with drones. So we are solving business problems and using aerial data to help solve those business problems and provide an ROI. So that's been our approach from the beginning too. So that was a little different. And then we, being business folks, we knew the importance of taking care of our pilot network, making sure that the missions we sent them on were missions we would be willing to do ourselves for the money we were paying, and then paying them promptly, et cetera. So I think all those things combined and just trying to do things the right way has led to some success.
DroneUp recently completed a project called Operation Last Mile. What was the project about?
The Project Last Mile critical drone delivery tests were a series of test scenarios performed at a 55-acre abandoned college campus in Lawrenceville, Virginia. This was done at the beginning of April, and we did it in partnership with the Virginia Center for Innovative Technology as well as UPS. This was at a time when COVID was a new and emerging threat on the horizon here in the United States. It continues to be. And part of the goal in doing this testing was to determine if we needed a way to perform non-contact deliveries at scale across a large urban or suburban area. Could we do it with drones, number one? And could we reasonably, instead of waiting for process, procedure, technology, and regulation that are 10 to 15 years away, could we reasonably do this with current 107 pilots, current generation aircraft, and then the supporting policies and procedures and current 107 regulations to make these type of operations successful, to deliver things which may have been, COVID test kits, to deliver medicine, to deliver really anything up to a couple pounds that was necessitated during an emergency. And what we found was that, yes, we absolutely could, and we could do it scalably. And with DroneUp's network of 10,000 remote pilots across the country, we look at this model as the foundation or the template of best practices, if you will, if you were to implement a technology to do these deliveries rapidly and scalably to meet the needs of an emergency. We learned a lot of lessons as to how that would be effective. And I think the most interesting lesson in my mind that we found out was, yes, it is very much possible. We can do this today with current technology, current regulation, and current pilots and training.
Can you describe the approach or the methodology that was used?
The test was performed, as I mentioned, on a 55-acre abandoned college, right? We found something that we wanted to use to simulate an urban or a suburban area, and we set up 7 different test scenarios. Each of these 7 test scenarios were designed to be more difficult than real-world activities. And what I mean by more difficult than real-world activities is we tried to add difficulty or complexity to these tasks for the pilots that we would really mitigate away. If you were going to perform deliveries at, let's say, a college campus. The sensible way to do it would be to drop packages right in the middle of a quad area where you'd have wide open space to do so and free of obstructions. We started by doing that. That was really our control variable. And through the 7 tests, we increased the level of intensity, the level of difficulty, up to a point where we all looked at ourselves as Joe and I was putting these test methods together and thought about halfway through it, there's no way that they're going to be able to complete every single one of these. What we found was every single one of the deliveries was made successfully with a single safety aboard. So the testing scenarios ended up being a control group where we performed 10 deliveries at 5 different locations, all within visual line of sight in an area that was easily accessible and clear of obstacles. At each delivery location, a 10-foot radius circle was drawn. And 10-foot diameter circle was drawn. And that 10-foot diameter circle was determined to be a successful delivery, all right? Anything outside of that 10-foot diameter circle, even though it was made successfully and dropped successfully, would not have been counted. So we started with that control group, and then we added levels of difficulty. So some of the levels of difficulty that we added were introducing flights that required maneuvering around and behind terrestrial obstructions, introducing flights that required communicating with a visual observer and utilizing that visual observer to maintain situational awareness as required by regulation. Some of those flights required tactical deconfliction of 3-4 aircraft at one given time, sharing the same airspace, assigning block altitudes, and managing the traffic flow. We learned a lot of great lessons about if you're doing drone delivery at scale, you're definitely going to have more than one drone, and you need a method to deconflict those air traffic operations in the absence of a UTM system we expect to be coming at some point in the future. The most difficult tests were performed at night with terrestrial obstructions and with visual observers who may not have been 107 pilots, right, to simulate a visual observer from the sheriff's department or a local police department, local emergency personnel performing that visual observer function if you didn't have a flight crew from DroneUp to be able to do that. And what we found was in every single scenario, our pilots were able to adapt, to rise to that challenge, and through our process, our procedure, and our training, rise to the occasion and meet the needs of that simulated emergency. So it was, I think, very impressive to all of us. And I think Joe would agree with me that at the beginning of this, we did not expect the level of success that we had. And, from my perspective, we didn't even intend to have the level of success because we were trying to, instigate some failures to learn something. And we were really blown away by, the capabilities that we were able to demonstrate.
How large were the payloads?
The payload that we put together was 20.4 ounces. It consisted of a 1-pound bag of sand, a medicine bottle that had jelly beans in it to simulate a real medicine bottle, a little box, and then an 8-foot tether and S carabiner hooks on either end, and a lightweight GSM bag, like a giveaway bag at a trade show or something like that. So all of that was put in the lightweight bag and hung on a tether, an 8-foot tether, and weighed 20.4 ounces.
Were the packages lowered to the ground or dropped?
The latest CDC data indicated that the coronavirus or COVID-19 virus could survive in particles up to 10 feet. So we tried to not have the drone come lower than 10 feet. So we had the 8-foot tether, and then we dropped it at approximately 2 to 3 feet from the ground.
If not for the virus concerns, would you have lowered the drones and the payloads all the way to the ground?
Through our testing, we determined that not having it on the ground was better because then the aircraft was stable until you let go. So you didn't have a situation with slack on the ground cause the release mechanism to behave differently. So the constant weight against the release mechanism and then releasing the mechanism while the package was still suspended. I mean, it could have been the same 6 inches, obviously anything above the ground, it would have been the same. We got a consistent feel for the pilot, consistent operation, consistent drop qualities. So releasing it above the ground was the best thing for us that we determined over time.
What about the experience of the pilots? Were all the pilots of relatively the same experience level?
We first issued a call out to our pilot network. And the way DroneUp's dispatch system is designed is we can search our network and find the pilots with the qualifications that we need within a certain radius of the operation, dispatch those pilots effectively automatically. We went in for an additional qualification step, and some of the qualifications that we looked for were the highest trained pilots that we could find, in our network. So we were looking at absolute minimums of 250 hours PIC, 100 hours in type, right? So the type of drone we were flying, which would have been an Inspire 2. We asked for documentation of that amount of flight experience. A number of the pilots we had had a public safety background and fly operationally for their fire departments, and we're also instructors for their fire departments, training their other pilots on drones. So the pilots that we had perform these missions were definitely at the highest echelon, not only of our network, but probably the highest echelon of drone pilots in general. And what was interesting was, of the groups that we had, they provided us a great deal of feedback operationally. We needed to know going into it what communication protocols we were going to use. How are we going to arrange crew members? We developed a third crew member position that 107 doesn't talk about called a load master. That load master is responsible for loading and unloading payloads, making sure the payload operation is safe, providing the pilot in command the physical logistics that he needs to get his aircraft set up with that payload, making sure the payload isn't entangled during the takeoff and during the drop. We also had to develop a communications protocol, and we leaned on the experience of our pilots. We knew what we wanted to do. We went into the exercise with a well-developed vision of how this would work. But as soon as you get on the ground and start experiencing the fog of war a little bit, you need that level of knowledge, training, and experience to step in there and constrain a little bit of the chaos. And we were very proud of the performance of the pilots in our network. And I think that shows a real thing that we take great pride in as DroneUp is we take great pride in having some of the best trained, best equipped, and best prepared pilots in the industry to tackle some of these extremely difficult, new, and novel missions.
Was there any experimentation with autonomous flights or automatic flight operations, or was everything manual?
We baked that into the scenario testing, and one of the specific tests we performed, I think it was test 3A and 3B. We performed 3A to 15 targets using pre-programmed. There's a slight semantic difference between autonomous and pre-programmed, and we like to say pre-programmed because autonomous, you would have the robot, which would be the drone, sensing the environment and making adjustments to what it's doing based on the environment. And to the extent that anti-collision would be considered autonomous, it was autonomous, but generally we would refer to this as a pre-programmed flight. So we pre-programmed the flight from takeoff to arrive at the landing zone, and then we had the pilots manually take over to do the final drop to make sure that that was safe and that there was no conditions existed that prevented the drop from being safe. And then we had the pilot drop it and then re-engage the pre-programmed flight to fly back to the takeoff spot, and then the pilots landed it manually. So those two legs of the flight in 3A were pre-programmed. And then we did the same tests exactly to the same targets with the pilots flying manually. And we compared the speeds, the altitude flown, the consistency of the altitude, the deconfliction when there were multiple aircraft in the air at the same time. And we compared those results, and we lay out those results in great detail in the report that we created at the end. And we share that transparently to the industry, because what we discovered was no one had done any of this kind of stuff at scale, and certainly no one who had done any of this had shared any of the results. And we felt it was important to the industry to go ahead and share the results. So yes, we did try some pre-programmed flights. Just in a nutshell, the manual flights, the pilots tended to fly faster than the pre-programmed flights. I happened to be the one that programmed the pre-programmed flights, and I wanted to make sure we had safe operations. And so I may have overdone the safety and flown higher out to and back from the targets and flown slower out to and back from the targets than the pilots did. And they did it safely too, but as a pre-programmed, we found that the pilots were able to do it faster. I think there's a place for pre-programmed flights. And I think as you get to a grander scale, you would find it helpful, especially trying to avoid flying over people, trying to avoid flying over moving vehicles. You would maybe want to ensure that the drone is taking a path that is the safest. So I think so. Brendan, do you have anything you want to add on the pre-programmed versus manual?
The thing that occurs to me about what we discovered is that automation is really useful for doing tasks that are normally dull, dirty, and dangerous, right? So if you have a pilot who's trying to maintain a very consistent flight path for a mapping mission, let's say, there's no way to fly that by hand. As a human being, you just can't maintain that level of precision without hours and hours and hours of training. If you're trying to maintain a flight route that is clear of terrestrial obstacles, and you need to make a descent through those terrestrial obstacles, right? And you need to make a determination about whether or not dynamic hazards are present, right? One of the challenges we had was we introduced moving vehicles as dynamic hazards, and the pilots had to deal with moving vehicles driving right into their landing site or trying to drive under them, and they would have to make tactical decisions on the fly to deal with that. There's not a good solution developed yet to handle those environmental variables. But where the software does really well and where the automation does really well is it frees up a pilot from having to focus on just getting that drone from point A to point B, just hand flying it from one point to another. So, I think what we determine in the future as this technology standardizes a little bit, as the industry develops best practices around delivery, what we're probably going to see is a hybrid approach, right? You have a pilot load up the aircraft. They're going to load up a flight route to a particular location. They're going to take off and hit go. That drone's going to get them to the location. And then it's going to be their responsibility to negotiate the hazards, make the drop, get the drone back up, to minimum obstacle clearance altitude or above, and then re-engage that autopilot that's going to take him back home. And as we were doing this, I kind of chuckled to myself because that's how the airlines have been flying for years, right? You take off pretty much by hand, engage the autopilot, manage the safety of flight, use your brain power to manage the safety of flight, and then disengage that autopilot when you need to, negotiate arrival and approach procedures. So I think that we, without realizing it, without intending to, kind of discovered what drone delivery operations are going to look like and the automation that supports them is going to look like in the future.
What kind of distances were tested?
So the minimum distance was about 300 to 400 feet away from the pilot, and the maximum distance, I believe, was 1,100 feet point to point. Now, there were some instances where the drone would have to fly a longer distance than that linear distance to get around structures and obstacles, that sort of thing. But minimum of a couple hundred feet and maximum of just under 40.
After the demonstration project, what did you learn that you think would transfer directly to the actual next step or the application of drone deliveries?
Speaking from the perspective of the training and procedures guy, in a lot of other areas of the drone industry, there are pretty well recognized standards about how to perform certain types of operations, right? If you're a construction company and you're implementing drones, there's a standard software package. There's a pretty standard workflow. If you're doing photogrammetry, you're doing photogrammetry, and pretty much everybody's software does it the same. What we realized is that we might have very clear objectives and we might have an ability to meet those objectives. But if we're going to scale this, we're going to need standards to get out in the industry as how that's performed. Everything from standards of how the drones are loaded to how external payload operations are performed, training for the pilots on some of the hazards of external load operations. Obviously, not every single pilot that you're going to get to fly these missions when you fly them at scale is going to be, an expert pilot. We had some of the guys that were flying with us that had over 1,000 hours PIC on drones. It's pretty unrealistic to think that the entire industry is going to be at that level. So we need to develop the standard operating procedures. We need to develop the training around use cases like this. The industry needs to coalesce on what those best practices are and the best way to train on it. We also need to develop methods for communication and deconfliction. We used a couple of different software platforms to manage deconfliction. Automation really helps because if you assign everybody a flight route and an altitude, you can be clear before everybody takes off. There's going to be no deviation from that. Obviously, in the real world, one of the tests was we had non-cooperative air traffic. So we had some partners that were flying with us. We had some other aircraft that were flying with us that were not visible on our flight management software. So we had to work with them to do what we would call in the the aviation world procedural separation, and assign those block altitudes and headings by radio. And it was as the air boss on my side, it was a very energy and human intensive process to do that. You have people stepping all over each other on the radio. You have people stopping and hesitating. At the end of the day, we got the packages to where they needed to be, and we did so quickly. But if we're going to streamline this and scale this, there needs to be a defined standard operating procedure. There needs to be a common language. There needs to be a common communications protocol. There needs to be a common training protocol. There should be standard aircraft that are utilized for this, loading configurations for the aircraft, maximum takeoff weight, CG calculation, the ability to do that. And then that's the next step that's really going to allow this to scale, to be able to perform these deliveries in kind of a commercially viable manner for the next emergency that we need to respond.
Did you learn anything that would translate into a best practice for landing area design or operation of landing areas, say for a hospital or even an emergency situation?
Yeah, so we learned a couple things. One of the things that we learned is landing areas need to be clearly identifiable. As we were flying, a couple of rainstorms came in, and we were basically painting these areas on the ground with fluorescent marking paint, which is a quick and dirty way. If you got to land something, draw a big, X on the ground and draw a circle around it, and the pilots can see it from the air. What we found as being helpful later on in situations where visibility is diminished, whether that operation be at night or whether it's difficult to define that operating area, is through some of the software we were using, we were able to define on the pilot's app exactly where that target is going to be, have them fly directly to that target and manage that operation through their instrumentation until they got to that final descent to make the drop. And usually when they're at that final descent, they're within 10 to 15 feet of their target anyway. What we found at night is in some of the scenarios, in scenario 7, which was kind of our last ditch effort to make our pilots struggle, and unfortunately, at least from my perspective, they were able to complete it with no significant challenges, was we didn't have a landing area. We had a simulation where we had a hospital that had a courtyard that was closed off on 3 sides. We had no landing area defined. The pilots couldn't see the structures or obstacles in that landing area. And we had a sheriff's deputy that was acting as the visual observer, talking that aircraft in. And the pilot and that sheriff's deputy that was acting as a visual observer negotiated a set of procedures within a couple of minutes to have the sheriff's deputy take his flashlight and identify the obstructions for the pilot, give them basic information about cardinal directions and altitudes, and then illuminate a landing spot on the ground. And the pilot was able to fly right to it. So standardizing that in a methodology that would allow anybody to do it and not just DroneUp's elite pilots, I think is very important. But we were surprised with as minimally as we marked out those areas, we were really able to successfully manage them. Joe, is there anything you want to add to that?
So I'll just reinforce what you said about radio communications. Some of our pilots came from public safety backgrounds and really had the radio communication cold. Others didn't have as much practice. And so to train everyone that they needed to have their thoughts complete and figure out concise phrases to use to get on the radio, because if you have 3 teams delivering at the same time and 1 radio channel, then you need to keep those communications brief. And each team established their own set of jargon. For example, say the drone is, you're the visual observer and you see the drone. You figure it's 50 to 80 feet up. You need it to lower down, but you need it to come forward to avoid the power line. You need it to go to the left a little bit to avoid the roof of the building. What does forward mean? What does left mean at that point? So we established some protocols that said, okay, orient yourself as if you're the drone, and forward means the drone's nose goes forward. Slide left, bump left, slide right. there's some different phraseology, and as we do this at scale, we'll need to nail this down and establish exactly what we want our pilots to use, exactly what we want our visual observers to use. When you count down the altitude of the package, 10 feet, 6 feet, 4 feet, 3 feet, drop, 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 those kind of clear, concise, published operational procedures, and demand that everyone follow them. Another thing was, from a safety standpoint, the checklist. If you're going to have drones operating at a high pace, they come in, they land, they get the new payload, they shoot back out. If you're trying to do it that kind of pace, you need to still maintain a level of safety and maintain the aircraft. You need to check certain things about the temperature of the batteries, of course, the level of the batteries. So incorporating checklists into the operation at a better, more consistent way, and take advantage of the opportunities of checklists. I mean, checklists keep things safe. We've proven that in manned aircraft. They would also certainly work in unmanned aircraft. So those are the two things I wanted to iterate as lessons learned.
You talked about the need for a common language to direct the drones. Do either of you know if there's already a common language used in the aviation industry that could be adapted?
We do, Randy. We absolutely do. And we tried using that a little bit. I mean, I come from the manned aviation background. So my natural mode of thinking is I'll call up a drone pilot on the radio and I'll say, okay, Bravo team, I want you to turn heading 270, climb, maintain 125 feet AGL. Turns out that if you're flying on, DJI Go, or you're flying on any other piece of commonly available software, you don't have a heading indicator. So the phraseology that I was using, which comes from, the Airman's Information Manual, which is kind of the FAA's standard document for radio phraseology and communication, is not useful if you don't have the right instruments to maintain situational awareness on your drone. So either we have to change the way that we communicate, or drone manufacturers and software providers need to make the instrumentation packages look a little bit more like what we have in the airplanes. Kind of to follow up on what Joe was saying, I was really impressed by a couple of guys who have a public safety background. For those that don't know, firefighters have a method of describing the sides of a building that they're fighting a fire on. So they'll say the Alpha side, Bravo side, Charlie side, or Delta side. And those are all in relation to where they're located or cardinal directions. Now, the two pilots that were on one of the teams were both firemen, and they were using that phraseology to direct each other. Okay, the landing pad is on the Charlie side of this building that's on your left, right? It allowed them to operate significantly more efficiently because the pilot, the load master, and the VO all shared, a common experience and a common communications protocol. Whereas, in some of the other teams, we'd have a VO that would say the package needs to be dropped on the west side of the building. The pilot would look down at his instruments and go, okay, I don't have a heading indicator. I don't know which direction is west compared to the drone. And they'd figure it out eventually and work through it, but it would take them a little bit of extra time because they'd have to, negotiate it and clarify it a couple times. So I think the answer is somewhere in between. I think my preference would be to stick with AIM phraseology because that's been used in aviation for years. And if you need to get into a situation where you're communicating with non-cooperative air traffic, if you've got, responding life flight helicopters, for instance, if you're in an emergency situation, you've got to speak a language that non-cooperative air traffic is going to be fluent in. But at the same time, there are some operational considerations for drones that are going to require us to go above and beyond and develop some methodologies of communicating that are a little bit beyond what we typically do.
And Randy, you've given me an idea. Our founder, Tom Walker, has a background working with special operations teams and obviously with helicopters, either the Coast Guard or special operations teams. There might be established jargon that we could adopt that folks coming from that experience would be familiar with, and we wouldn't have to reinvent the wheel. So that's something I'm going to investigate. How do the helicopter folks do it?
Joe or Brendan, is there anything that we missed that we should talk about?
I don't think so. Joe, can you think of anything?
When I think about delivering under the current regulations, I think it's incumbent on the drone industry and the operators in the drone industry to explore, understand, and push the current regulations, because the FAA really does want to see drones succeed in the airspace, but they want it to be done safely, and everyone wants it to be done safely. So one of the things about this exercise that I felt good about was we had been told you can't use Part 107 rules to deliver, but we studied the rules very carefully, and you can. Using visual observers with radios, we can push the envelope, so to speak, do it safely, and keep this industry moving forward. So this is one of the themes that Tom Walker, our founder, has used for a long time. Let's not bellyache about what the FAA won't let us do. Let's figure out what the FAA will let us do, and let's go do it.
Were either of you surprised by anything that happened during the test?
You want to go first, Joe, or do you want me to take
Brendan, I think I know what you were surprised at, Brendan. You tell him first.
Yeah, absolutely. I was entirely surprised at the level of success we were going to have. I mean, like Joe, I shared a skepticism of the capabilities that we were going to have, with current generation aircraft. I mean, we were flying Inspire 2s. These are aircraft that are designed for cinematography, right? I didn't expect that we were going to be able to, even with payloads that are within the payload weight limits prescribed by DJI, I couldn't imagine that the technology would perform. I didn't imagine that we were going to be able to coordinate as many deliveries as we could. And I didn't think that we were going to be as effective at performing those drops. So what this, even in a scenario where we designed the test scenarios to be really as difficult as possible and far and away beyond what these pilots would experience doing delivery operations in the real world. So it surprised me in a very positive way. And I think it opened my mind and humbled me to the level of possibility that we have developing, these use cases in the future and pushing the industry forward.
Joe, how about you?
I will reinforce what Brendan said. I was surprised at how well the pilots performed, and we could not design scenarios that stumped them. I didn't want to make it just super crazy impossible, but I really thought they would struggle more than they did. And so I'll reinforce it also by my observations that I was surprised at how quickly the pilots adapted and fell into a rhythm that made me really believe that drone deliveries at scale can happen. The level of professionalism they showed and safety conscience that they showed at the same time, going fast, turning the aircraft around fast, finding the delivery spot, flying to it. They got faster and faster at just the turnaround, the flying, and it became a well-oiled machine in such a quick fashion that surprised me. And I went away from there thinking, wow, this really can be done. I was surprised at how fast they adopted the radio procedures, the flight procedures, the safety procedures, and how quickly it gelled in, and they got very good at it very fast.
We go to great lengths at DroneUp to have the best trained, the best equipped, and the most proficient pilot network, in my opinion, in the industry. And I think that part of what we showed at Lawrenceville is we do have that, right? And those skills to adapt and conquer are really important in those challenging scenarios, whether they be deliveries or whether it be, commercial operations or governmental operations that are, extremely challenging and require you to think on your feet and adapt. So as much as I think Joe and I went a little bit above and beyond to make those scenarios pretty sadistic for our pilots, they were able to tackle them, move forward, get into a rhythm, and get done what needs to be done.
Now that the test has been completed and the report has been written, what's the next step?
We've actually been approached by some companies that believe that delivery is an important part of their future. We have a number of projects that have been defined. We think we may go back to that campus in Lawrenceville in the relatively near future to extend the testing, maybe fly farther distance, maybe fly heavier payloads, try some things that some of our potential customers out there have asked us about. So I think this is just the beginning.
And for my final question, what message would you like to leave regarding the future of drone delivery?
The future of drone delivery is bright, Randy. We're very excited about it. I think what we've shown is there's this, perception that drone delivery is, 10 to 15 years away because the technology is not there, the regulations are not there, the procedures not there, et cetera. As we look at commercial drone deliveries at worldwide scale and having it, become a standard everyday practice, that may be true. But I think what we demonstrated in Lawrenceville is there are absolutely things that can be done today, and we can do things at scale today that may not have been possible even 6-8 months ago with the technology that we have, the procedures that we're developing, and the network that we have, the pilot network that we can tap into. So we're excited about our future opportunities to build on these successes, develop the standard methods and practices for performing drone delivery, develop the pilot training, and push that industry, just 1 or 2 steps forward to start realizing some of the value that drones can provide for logistics operations.
That's it for episode 273 of the Drone Radio Show. I hope you enjoyed hearing from Brendan Stewart and Joe Fuller of DroneUp. I want to thank Brendan and Joe for taking the time to speak with me. If you want to learn more about DroneUp or want to connect with Brendan and Joe, check out the website at droneup.com. You can also view the report on Operation Last Mile, Critical Drone Delivery, by clicking on the News tab. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to DroneRadioShow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.